This is chapter 3, section 6. So now we're getting into compound inequalities. So what we're looking at, we want you to be able to solve and graph inequalities with the word and with the word or. So compound inequality is just two separate inequalities combined into one. On this page, I would suggest that you write this part, and then any of this that you feel necessary. If you don't feel like you need this picture and you understand it without it, that's fine. If you feel like you need it, I would definitely pause the video and write it. So here's what this says. A compound inequality consists of two distinct inequalities joined together by the word and or the word or. So we're going to show you two separate examples, okay? So here we go. We have our first inequality, x greater than or equal to 3. And if we asked you to graph it, you would be able to show that. So we have a solid dot because it's equal to, and it's greater, so it goes to the right. Here's our second inequality, which is x is less than or equal to 7. Again, a solid dot going to the left. And now if we combine these two with the word and, it looks like this. So here's what they did here. They took basically a dotted line and drew it down and said this one starts here and this one starts here. So they started off where it started and did a dotted line all the way down, and where this one started and did a dotted line all the way down. And where those two overlap, so it's only this section between here and here and here and here, that's what this new one becomes. And notice that this one was a solid dot, so this one also has to be a solid dot. This was a solid dot, so this was a solid dot. If either one of these was an open, they would be open down here. And so now this is the inequality of x being greater than or equal to 3 and x being less than or equal to 7. If we use the word or instead, here we have two distinct inequalities. X is less than -2, x is greater than or equal to 1. When we do that and we join them, it basically looks like them two separate but on the same number line. So these are a little bit easier to do because it's just basically drawing this one on the number line and this one on the number line, and then just drawing them both on the same number line. All right. So what compound inequality represents the face? So we want to write these together. Okay. All real numbers that are greater than -2 and less than 6. Okay. I want to go back one slide. Forgot to talk about this part. When you have these inequalities separate, like x greater than or equal to 3 and x less than or equal to 7, you can write them basically combined as x. If you just look at this, like this part right here is the same as this over here. We just flipped the x. And then this part right here is the same as this right here. So you put x in the middle. So this is, x is between, basically, x is greater than or equal to 3 and x is less than or equal to 7. Bingo. Okay. So what compound inequality represents the phase? What I like to do, especially right away when this is new, is write them separate. So how about greater than -2? X is greater than -2. And the other one is x is less than 6. X is less than 6. So now if I tried to combine those, I put x in the middle. I say -2 is on this side and 6 is on this side. So x is less than 6 and x has to be greater than -2. There's no equals to, so we're not going to put those. So that's just those two combined. And if we had to graph it, we go anywhere from, We'll start off with 0 right here. Here's -2. Here's 2. Here's 4. Here's 6. So x has to be greater than -2, so it's an open circle around -2, and less than 6, an open circle here. And then we just shade this in really well between them. All right. If you need another one, there's another example in the book. You can take a look at this one, but for time's sake, we're going to move on. Now, solving these, once you get used to it, you can solve it without doing this step, but I think right away, I would split them apart. So let's break them apart to just this part, -3 less than or equal to m minus 4, and then this part with the m on the left side, m minus 4 less than -1. And solve both of them separately. So we add 4 to both. And we have m is less than or equal to 1. And over here we add 4. And we have m is less than 3. And now we can bring them back where m is greater than or equal to 1 and less than 3. Okay? And then if we graphed it, we're going to have -2 right here, 0, 2, 4. So where m is greater than or equal to 1, here's 1, that's equal to, so we're going to fill in the circle. Here's 3 right here, and then we just fill it in between. Okay. Now dealing with OR, what are the solutions with OR? And then we have to graph. So OR, we write them separate. We can't combine them into one like we did here. We can't combine them into something that looks like this. Okay, or always stays separate. So we solve both of them. So the first one, subtract 2 from both sides. We get 3t less than, what is that, -9. T is less than -9 divided by 3 is -3. This one, we're going to subtract 5 first. We get -4t less than 1. Divide by -4. When we divide by a negative, t is greater than -1/4. So we're going to have t being greater than -1/4. Greater than -1/4 is over here, and t is less than -3. Okay, you notice how that doesn't work, right? -1/4 less than t. There's no number that fits between them, and that's why we can't write them separate. So like I said, we have to keep them, or I'm sorry, we can't write them together. We have to keep them separate. So this or this. That's our inequality solved. So this would be your answer right now. And then graphing them, there's 0, there's -2, there's -4, less than -3. So we're going to say here's -3 going this way. And -1/4 is about right here. And it's greater than, so it's going, going this way. So they are two very separate. All right, last part, interval notation. I suggest that you take a look at this. You take some time real slowly. Interval notation includes the use of 3 special symbols. So those symbols are a parentheses, a bracket, and the infinity symbol. And here's what it means. This is basically your start, and this is your stop number. Okay, so this goes from 2, it starts at 2, and it goes all the way to infinity. It goes forever. It's a bracket because you use the bracket when the endpoints are included, when it's an equal sign. You use the parenthesis when it's not. And so anytime you go to infinity, it can't be included, so that's why it's a parenthesis. Here's another example. This goes from negative infinity, all the way up to 2. And it doesn't include 2, and that's why it's a parenthesis here. See here, it's a bracket because it's included. Excuse me. Here it's a parenthesis because it's not. Here, one with that's an and that's between the two. 1 is not included, so it's a parenthesis, and it goes up to 5, which is included. It's a solid dot, and that's why it's a bracket. And then here's how you would write them using ors. From negative infinity up to negative 3, parenthesis, because it's open circle, or 4, it's a bracket, because it is included, up to infinity, and it's a parenthesis because it's not included. So those are some of the things that we're going to be looking at in this section.